again. So I'm hoping that you've all drawn your graphs, and your graphs, when you had your temperature and your resistance, sorry about that, it's like flapping at the end of the last video, look like this. A really nice curved line. So what I'd like you to do now, please, is sketch your graph. And by sketch, I mean draw that general shape, draw your axes, but you don't need any numbers on them. And then we're going to add notes in your book. So here we go. Graph to show how the resistance of a thermistor varies with temperature. Resistance decreases when temperature increases. Now, so that's a headline, really. However, you can see it's not a straight line. So it's not like that. Again, really wonky lines, really rubbish at drawing these. So you need to know why this happens. Thermistors are made out of something called semiconductors. Now, I'm sure you've heard of conductors and you've heard of insulators. Semiconductors sit somewhere in the middle, and basically they can change how conducting they are. So thermistors are made out of something called a semiconductor. When a thermistor is hot, the electrons receive enough energy to break free of their bonds and carry the current, lowering resistance. And vice versa. When it gets cold, the electrons get trapped and there's less of them around to carry the current. So there's a higher resistance. So the hotter it is, the more electrons, the lower the resistance. Now there is something, so once you've written those notes, there is something that's very, very similar to a thermistor in the shape of its graph. However, rather than depending on temperature, it depends on light. And so we're going to look now at a light-dependent resistor. And here, resistance decreases, fine, when light increases. So rather than temperature, when light increases. So the brighter it is, the less resistance there is. And it's for the same idea, really. So light-dependent resistors can be shortened to LDR, just FYI. So when an LDR is under a bright light, the electrons again receive enough energy to break free and carry the current, lowering the resistance. Now you might be thinking, where would I use something like this? Where are these, relevant? For a thermistor, you could use it in your heating. So I'm pretty sure most of you will have a heating, what's called a thermostat in your houses, and that is something that's set to a certain temperature. And when it gets cold, the heating turns on so that it warms your house up. In an LDR, it might be something like street lights. So your street lights outside your homes will turn on when it's dark, and they'll know it's dark because they will have LDRs inside them. And that's it. Now, you may notice this lesson is slightly shorter. You've got a few notes and a graph. I've just received an email from Mrs. Chaplio asking us basically as staff to take it a little bit easier with you so that you're not feeling the stress of trying to rush everything into a lesson. So I will obviously chat to you on Zoom this week, and if you are finding actually, Miss Wallace-Abbott, you could put a bit more into these lessons, please let me know. That's not an issue. But I don't want to overload you. So we're trying it slightly less, and we'll just play it by ear. If you want more work, I'll give you more, but let's try it slightly easier. So thanks everyone, and I shall see you soon. Bye.